Good morning, everyone, and thank you for joining GitLab and HashiCorp for today's webinar. We will start momentarily. We'll give people a couple of minutes to trickle in before we start. And I said good morning, but I should have said something like good morning, good evening, good afternoon, because I looked at the registration page or list, and I see people from all over, including, yeah?
Aren't we live?
Yes, we are. I think we are live. Giving people a couple of minutes before we get started. And can you hear me? Brad, do you hear me?
Yep. Coming through loud and clear.
Perfect.
Thanks for setting this up.
Oh,
looking forward to it.
Yeah, it'll be a fun webinar. I like to give people a couple of minutes to finish, logging in or whatever technical things. So we have most participants already in before we get started at 9:02. And so 9:01 right now. Yeah, some participants I saw were coming from Australia. I don't know if they'll be watching live. Probably will be watching after the fact. Okay, I think it's 9:02. It's a good time to get started. So hello, my name is Alex Velasquez, and I'll be helping facilitate today's webinar, which is titled The Peter Parker Principle of GitOps, Proactive Measurements to Ensure Security. We know that with great power comes great responsibility. So we'll explore here how GitLab and HashiCorp, Terraform, can help DevOps teams fulfill their security responsibilities. We will start with a presentation. We'll follow it shortly with a demo, and then we'll have a Q&A session throughout the entire webinar. Please feel free to enter your Q&A, your questions on the Q&A feature. And also please know that this webinar will be recorded, and the recording will be made available after processing. It usually takes a couple of days to have it processed. So let's start by having our speakers introduce themselves. We'll start with Brad Downey from GitLab. Brad, do you want to introduce yourself?
Thanks, Alex. Good morning. Really excited to be here. My name is Brad Downey. I'm a strategic account leader for GitLab. My job is to help clients accelerate their GitOps and DevOps journeys and move their application infrastructure into their various different clouds.
Thank you, Brad. Thank you, Brad. Now we also have Kyle Ruddy from HashiCorp. Kyle, do you want to introduce yourself?
Yeah, absolutely. Thank you again for having me. My name is Kyle Ruddy. I work at HashiCorp, where I am in the technical marketing group that focuses on Terraform.
Great. Thank you both. We are very excited to have you speaking at this webinar. So without further ado, let's get started with an overview. Brad, take it on.
Thanks, Alex. So speed is the key factor in success for business these days, specifically the ability to run fast experiments and adjust your strategy based on those results. Cycle time is the amount of time it takes from a single experiment or feature to go from idea all the way to production. This encompasses all teams across all areas of the business. The shorter we can make that cycle, the faster customer feedback and adjustments to the business strategy can be made. Mark Andreessen is quoted as saying, cycle time has been the most underrated force in determining winners and losers in technology.
Okay, so let's take this concept of speed and apply it to infrastructure. Going back to when I first started as an admin and engineer, the speed came from muscle memory of how fast I could click through tasks as they were being requested. Then Terraform came along and gave me the ability to automate my workflows. meaning that I didn't have to worry about whether or not I was fully awake, because I'm not really a morning person. And it also added the ability that every single operation was done consistently, not just for those one particular request that came in, but for all the requests across all the services that me and my team were managing. Finally, it put that organization at a point where I could be removed as an active dependency for each one of these requests. Basically, I could set up the workflow, have it approved by the management teams, and then the requesters could come along and provision their own resources, self-service style. So one thing that I didn't really mention with that is security. How does security play into this? Some of the common focus points are on state file storage. State files can contain sensitive information, including credentials and unique IDs and some other items that we don't want out in the public domain. So how can we ensure that only the appropriate people have access to those things or can request exactly what they need to use within these environments and services? So Terraform has a vast and amazing community full of open source providers and modules. So how do we ensure that the items we're using from that open source community are safe and adhere to our organization's best practices? And lastly, how do we verify that once all of this stuff is set up and put in place, how do we ensure that it maintains that level of security through different updates and upgrades along the way? So, and that's really where the Peter Parker principle of GitOps kind of comes into play. So, if you're unfamiliar with this, in Spider-Man, regardless of which Spider-Man is actually your favorite, Peter Parker's uncle explains that with great power comes great responsibility. And that same concept is applied in GitOps as well. You can't risk jeopardizing security for productivity gains. And that's why we're here today with GitLab, to really show how HashiCorp's Terraform can combine with the built-in capabilities of GitLab to increase productivity without having to sacrifice the speed of automation nor the requirements and enforcement of security. So first, I want to talk a little bit about Terraform Cloud. For those of you that are familiar with the Terraform CLI, this is what's known as an enhanced remote backend. That means that not only can you store, or not only can Terraform Cloud securely store your state files, but it can also perform executions remotely on top of that. So you no longer have to really depend on your local system to perform those tasks, especially when they're long-running tasks. Now, we've also built in a ton more features and functionalities, like providing a private module registry where we can store those approved and hardened resources for easy reuse. We can configure role-based access control, or RBAC, to ensure that users have access to those items they require. Then there's Sentinel, the policy as code framework, which can be configured to check every single Terraform operation and enforces its compliance to our organization's best practices, as well as some of those other compliance programs that are out there and existing that we have to adhere to as well. Then lastly, there's the ability to provide logs so that we have visibility across the entire Terraform organization to have a full understanding of what's happening in our environment.
So what is GitLab? GitLab, if Terraform has turned our infrastructure into code, then we need a software development platform to manage and collaborate on that code. So GitLab is a complete DevOps platform delivered as a single application, one place for your single source of truth for all your infrastructure as code, a place to collaborate with your peers and stakeholders, and a way to automate everything after approvals in a single, easy to consume platform. And together with HashiCorp, GitLab can help you collaborate in this single application with all stakeholders from various parts of the business, automate the approvals and the execution of your infrastructure as code, and secure your applications and infrastructure along the way.
So those scenarios that were on that previous slide really show the capabilities of how GitLab and HashiCorp can join together for increased agility through automation or even integration within those existing CI/CD pipelines that your organization might have. We can also help reduce risk with the ability to store and protect resources and enforce those permissions across our entire org at every level through some of the industry best practices through single sign-on. And then even help reduce some of these costs by visualizing the cost of deployment through Terraform, and again, enforcing those best practices through some of those Sentinel policy as code checks.
So we're going to move over into the demo portion. Before I do, I want to walk through kind of what you're going to see and what the high-level workflow is. So here's a representation of the workflow that we're going to follow. In the left, the engineer proposes a change in the form of like a git commit. This is just an update to the code in the project. That change is then captured in the form of a merge request. The merge request is a single source of truth for this change. Who made it, why they made it, what tests were run ahead of time, who approved it, etc. All of this information is captured in a single place that can be audited, reported on, down to the specific line of code that changed. After it's approved and merged, all the automation kicks in to execute and retest all of those changes. This is what we consider as GitOps. So in our demo scenario here, we've got a Black Friday event. The Black Friday event is cross-functional, so it's going to include the marketing and development team, the infrastructure team, and they're going to work on various different areas of their expertise. So marketing is going to work on promotions and discounts, and development's going to work on website changes, and infrastructure is going to work on the auto-scaling. And this is great. And this is how management sees it, a very nice little left to right flow where everybody's got their own work. The reality is that there's a lot of interdependencies here. And development waits on infrastructure, infrastructure waits on marketing, marketing waits on development. And we've got just a lot of different interdependencies here. And we need a single place to collaborate on this. So there is a better way. And this is the combination of GitLab plus HashiCorp, specifically Terraform and Vault. And where marketing, development, and infrastructure all use the same application, the single source of truth, that common database to manage and execute all of their various different tasks. And then applications like Terraform are going to automate the execution of that and keep all of our infrastructure healthy. So with that said, I'm going to go ahead and share my screen here. 1 second. All right, somebody stop me if you can't see. What we've got here is we've got Lab brought up, and I brought it up into the traditional Gantt chart view. This is great for the executives. They all want to know what's the progress, what's going on. They don't care about the tasks that are underneath. They just want to see, when am I going to get my results? And what I can see here is I've got my Black Friday epic here, and each team's got their own sub epic underneath that. And we get a status report on each one of these milestones. So we could see that infrastructure is 15% complete, development's 25%, and marketing 61%. And that's great. But let's click down into this a little bit more and see a little bit more detail. I'm going to move over to the milestone screen here. Maybe. There we go. Nothing like a little slow internet in the morning. I'm going to click into my Black Friday milestone, and now I start to get a little bit more detail. I can start to see where things are from a burn down chart perspective, how many points or story points do I have left, or how many tasks do I have open, and if I meet that over time. And in a perfect world, this would be a nice angled graph here all the way down. But as long as we get by November 26th, we get down and to the right, we're going to be good. And if I was a project manager, I'd be able to come down and see what tasks are open and to these. And this is down to the task level. So an update to an individual task automatically updates everything upstream to give a single place for data input and visibility all the way up to that executive viewpoint. So I'm going to play the junior engineer in this demo scenario here. I'm going to jump into my issue board so I can see what issues are out there and which ones that I want to work on. And what I see here is I can see sorted by column. Now I can change this view on however I want. And if I needed to move a task around, I could just pick it up and move it. But I can see infrastructure. They have their column. Development's got their column. Security's got their own label, and marketing's got theirs. So I can easily see who's working on it. I can also see if an issue is blocked. So maybe we can't work on this one because it's blocked by another issue. So it allows me to quickly identify the ones that I can work on, I can contribute to, and do quickly. So as a junior engineer here, I'm going to pick this AWS Elastic Load Balancer update. I'm going to click into this one here and have a quick read on what the issue says. So let's see, because it's Black Friday, we need to have need to support the appropriate amount of traffic and that it's tagged properly. Okay, looks like something that I can solve. So what I'm going to do is I'm going to create a merge request, as we looked at in that diagram. And if the issue is the problem statement or what I'm supposed to be doing, then the merge request is the fix to that. So this is where I'm going to capture all of my changes and understand what I need to do. So I've got this in draft form here, so everybody knows that I'm working on it. And it's not ready to be merged yet. I'm not finished. I'm going to just go ahead and assign it to myself to start. And I'm going to take a look at this, and I can see that everything is logged here and time-stamped. So I'd be able to understand who did what when, if we ever needed to go back. Now, what I can do is, if I'm a big fan of Git and working out of my computer, first thing I could do is I could check out this branch. So if I did that, I get all the Git commands here because nobody remembers what Git commands are. You always have to look those up. So this is a nice way just to copy and paste this, pull this down to my local machine, make the changes, and push them back up. But instead, today I'm going to use the web editor, the web IDE, because it's a quick, easy way, and I know that I'm just going to be able to knock this change out. So if I click on this here, I'll brought into a nice kind of web editor format here, and I can see all of my files in my project. I've got my Terraform projects here, and I bring up my main.tf, and I see, okay, I've got these modules here, and these are in our private organization in Terraform Cloud. So I know that these are safe, and I know that I can use these, and they've been approved by my organization. So I need to adjust the count here and add some labels based on that issue. So I'm going to go ahead and do that. I'm going to just create some good best practices around traffic management. I'm going to add some tags, and I'm going to adjust the count to 5. And that looks good to me. And I'm going to go ahead and look at that, and I can see the diff here. Okay, it looks like I'm adding just those components. I didn't accidentally add something else. Let's see. I'm going to put my little commit message in here, change count to 5 and add tags. Okay. And I'm going to commit that to my branch that was automatically created when I created my merge request. And what's happening here is my pipeline, which is my automation, is automatically kicking off. And I can see a little status message down here that my pipeline is moving along. And this is where our senior engineers have set up all the best practices and have set up the testing framework to wrap around this. So I'm pretty confident that if I look at this, I will see that I'm doing things correctly. Uh-oh, I got an error here. Let's take a quick look at that. So I'm going to click into this job. See, okay, let's see. Let's scroll down to the bottom. Terraform format fails. Oops. Kyle, who's my senior engineer in this scenario, he's a big stickler to formatting. So better fix that before he sees it. Let me see here. Okay. Glad I got notified ahead of time. Go ahead and open up my editor again. And let's see here. Okay. Oops. So we're going to go ahead and change this. 1 second. Go ahead and update these, spacing here. Likes all the little equal signs lined up. Okay. So we're going to say fix formatting. Okay. I'm going to rerun that commit. And this is going to kick off our pipeline again. Okay, so it's running. Let's take a look at that pipeline. Launch into that. Okay. We'll wait for our validate job here. If I wanted to see what's happening while it's running, I could click on that and get a live report. Oh, job succeeded. That's good. So let's go back to that pipeline. And I've got 2 additional jobs here. So let's click into this real quick. All right. Kyle, can you tell us what we're looking at here?
Yeah, so here we are in the Terraform Cloud console, and this is what matches up to what's happening on GitLab as part of that CI/CD pipeline. And so what we're seeing is the end result of what's known as a speculative plan. This is basically just laying out the groundwork for what is expected to happen if we go ahead and deploy this configuration as it is. So we can see all of the items that are going to be deployed. We can even see some costs. So as part of this, we're deploying ELBs through AWS. Each of those have a differing cost. So since this is Black Friday, we're going to need to ramp that up. So we can see some additional ELBs being deployed. And then below that, we can see our Sentinel policy as code of policies that are being checked. And in this case, we can see the top one, which is for general costing. It's just ensuring that we don't deploy an environment or a piece of infrastructure that's going to be more expensive than $20 a month. And in this case, it's Black Friday, so it's only going to be an advisory failed. So we could say, we approve it anyway. We accept. This is only for, to support some burst capacity.
And I notice here that because my code changes haven't been approved yet, I can't apply these.
Correct. Yep.
I'm going to jump back into GitLab here. So I went a little too far. Go back into my merge request now that I've seen my Terraform plan execute successfully. And I'm feeling pretty confident about this. I'm going to just do a quick review here. I got my changes. It looks like I've got my spacing correct now. My pipelines are passing. So I've got my green check marks here. Now I'm ready to hand it over to my senior engineer. So here, what I'm going to do is I'm going to go ahead and mark my work in progress complete, and then I'm going to ask Kyle to review this for me. So at KMR, Kyle, can you please review. I nailed it. / table flip. Okay, and I'm going to comment that. And we're good to go. He's going to get this notification. And in the background, he's going to take a look at it. He's going to review my code. He's going to understand, okay, is this a change we want to make? He's only brought in at the end here. So I'm able to do all the work, do all the testing, make sure everything lines up. As the junior engineer, I've put all of the upfront effort into it. And I want him to just take the time to review it, understand if it works, if he thinks it's good. What he's going to do is he's going to approve it. So we'll see the approval pop up here. And we will also see if once it's been merged, we'll take a look at the pipeline after that. Let's see. Kyle's super busy.
I'm such a stickler on formatting, and I'm also a huge fan of using one of the new improvements to Terraform 0.13 with that the count argument for our module usage. You know, I'm going to be ecstatic to go through and approve this and hit the merge button. So hopefully you should see the approval come through and working on the merge now.
All right.
Let's see.
Oh, little refresh here. Looks like Kyle's doing some work in the background here.
Oh, there we go. There's the merge. Perfect.
So now I hit refresh, and I can see already that it was approved by Kyle. I could see his check mark there. So we don't need to worry about, so now if we go back, if something goes wrong, it's totally his fault. And we can see it was merged in by him. And we've got a new pipeline running here. So let's take a look at the new pipeline. Once again, all of this is logged and timestamped, and this lives in indefinitely. So we can always go back and trace this. So let's take a look at the new pipeline running. And it looks like we're already finished here. So I'm going to pop into Terraform Cloud Job again. So now what we see here is the plan is finished, the cost estimation is the same, and apply is pending. Kyle?
Now, the one thing that we're missing here on Brad's screen is the ability to go ahead with the apply. So, you know, if we notice the plan exactly the same as what we saw in the prior step, cost estimation, policies passed, exactly the same. However, we're now ready to go ahead with the application, but in this case, we're using some RBAC, some permissions to perhaps limit Brad so that, you know, maybe he's not at the right level to hit the apply button. So I'm going to go ahead and hit the confirm and plan on my side, which should hopefully pick up here shortly on his screen. And there it goes. So we can see that the run is being confirmed, and we're now deploying our ELBs to, you know, set up and manage our Black Friday workloads.
Awesome. Now I'm going to go back into GitLab here. And what I know is that this, by automatically merging this and executing that, it's closing out my issue. So if I go back to my issue here, I can see that my issue is now closed out, and it's going to update my milestone. And now automatically all of this data flows back up and through all the status reports. So no more long status meetings of, have you finished this? Are you done? When can I close this out, et cetera. All of this is done by me entering the code and Kyle approving it and merging it. All of that data then flows back up into GitLab for all of the proper reporting and planning and update of all business stakeholders. So with that said, I'm going to stop sharing here and should be back on the slides. And we're going to move on to takeaways and Q&A. So with GitLab and HashiCorp, what you get is a cloud-native application. Both Terraform and GitLab can be consumed either in your own private data center or in the cloud as a software as a service. Completely cloud agnostic. Now we showed AWS today, but works equally as well with Google, Azure, and many other clouds. We take a very code-driven approach. So we started with, our planning obviously moved into actual code updates and secure policies and pipelines. And we're able to do everything in an automated fashion.
So, and when it comes to Terraform and Terraform Cloud in particular, this is something that's available, and you can consume different levels, different tiers as they were, depending upon what you need for your environment and your organization's usage. Now, there is a free tier. That's what I was mentioning before about the enhanced remote backend. That means that you can upload or rather you can store your state in a secure manner. You can have Terraform Cloud run those executions for you. And then you can jump into some of the other tiers, which add some additional features, such as what we showed today, where Brad and I could access the same exact code, the same exact plan and apply, and being able to share and work together to come to that common endpoint. We can also do things such as Sentinel and policy as code. That's also available in that middle tier. And then we get to our newest and latest and greatest tier, which is called the business tier, which adds support for those audit logs so that we can get visibility across the whole environment so that we don't have to go through each individual section. We can add SSO to streamline the login and new user addition process. And then we even get to the point of being able to, be able to consume Terraform Cloud as this SaaS-based offering within our on-premises environments through either having some static IP addresses that we can open up firewall ports to send out our remote executions or access to our on-premises GitLab enterprise offering. Or we even can run some of those executions locally through the Terraform Cloud remote agents.
And very similar to Terraform, GitLab is an open core company. So we have a open source tier within our application. So starting on kind of the left there, we've got our free and open source, both as SaaS or self-managed in your private data center or your private cloud. We also have 3 paid tiers that add additional features, functionality, and support as you grow through that, with the highest level giving enterprise-wide operation and visibility, project planning, high availability, and security and compliance. And with that, we're going to invite you to go to gitlab.com or app.terraform.io to get started. You could sign up for your free accounts and start experimenting today. We're going to move into the Q&A portion of the webinar. And I'm going to hand the microphone back to Alex for a second to see if we've got any Q&A in the queue.
And we do. Thank you so much, Kyle and Brad, for a presentation. We have a few questions. So the first one is there a way to modify the state file in Terraform Cloud?
So generally, I'll take that one, Brad. Generally, it's not a best practice to modify the state file. You really want to modify the configuration file, which then generates that backend state file. Now, I know there are certain situations where you may have to manage that state file directly, and that is not something that you're going to want to do with Terraform Cloud. Again, with Terraform Cloud, we'd rather you follow the best practices of updating the config file and having the state file being updated in that manner.
Thank you, Kyle. Can GitLab be run in my private cloud?
Yeah, I'll take that one. So GitLab uniquely has a single code base. So GitLab as an open source project can be downloaded and installed in your private data center in your private cloud. So that you could run it in your AWS VPC and your Google Cloud instance. You can run it on your VMware data center in your location behind your firewall. You could even run it on a Raspberry Pi. We also have a SaaS service if you're not a big fan of updating patches and updating software on a regular basis. So we give you all of those same capabilities. It's the same code base and can be run anywhere that you want. It's a really unique differentiator. It allows us to move extremely fast and give customers the choices that they want on where they want to run their Terraform instance. Or excuse me, GitLab instance. Ha.
Another that I think is related, can I use Terraform Cloud for my private data center?
Yes, and I'll take that one. So absolutely. So a lot of the niceties and features that have been added to Terraform and Terraform Cloud here over the past, some couple months, some over the last year, has been really with that end goal of helping to facilitate the manner in which we operate Terraform within those either on-premises environments or those that are segmented off from, having internet access. So Terraform Cloud is available in the public domain. It's app.terraform.io. So we can either do this in two manners, which you can open up firewall ports, which can connect out to the Terraform Cloud service. We have those publicly posted. It's available in our documentation pages. However, there are some situations where security groups aren't very favorable in opening up firewall ports. So the other option is that we can use the Terraform Cloud remote agents, in which case those are essentially Docker containers or binary builds that you run either in your on-premises environment or in those network segmented environments. And those Docker containers or those agents are going to reach out to Terraform Cloud, which means that there are no firewall dependencies or any kind of security, real security implications going with that, because everything is SSL encrypted through the entire process. And it reaches out, asks for a new job, and then it pulls that information back. So there's some really nice features that are available with that, and that was made available here in the past month or two with the Terraform Cloud business tier.
Thank you, Kyle. How's a password managed on GitLab?
I'll take that one. So we only need a single API token to access Terraform Cloud. So that links those two together. And what we did is we injected that into those pipeline runs to allow it to execute and share the changes back and forth for when we change the code base, and to be able to push and pull statuses. So actually, 2 days ago, we launched GitLab 13.4 with support for HashiCorp Vault secrets that are able to automatically pull secrets out of Vault and inject them into your pipeline runs. So while we didn't do that in this particular demo because it just came out, I have tested it out, and it is an amazing feature.
Great. That's actually in line with the question here. Where do you see the GitLab integrations with HashiCorp tools, Terraform, Vault, etc., going in the future?
I'll take first stab, and then Kyle, maybe you can chime in and add your thoughts as well. I see this going together really well. We continue as two different companies with very similar models, with a high support for open source and then adding features on top of that. I see us getting closer and closer together. So we're already very close in terms of Vault. We're very close with each other in terms of Terraform and things like Sentinel and Console. These things will all continue to get better and better and get closer and closer to GitLab. That's my vision, and I think it's a great one. Kyle, what are your thoughts?
Yep, I'm in the exact same boat with you on that one. I think what we saw today in that demonstration was a really good view of the integrations that we provided today, being able to take those like speculative plans as well as those Sentinel, the rule checks to verify and feed that into GitLab and in that environment, all the way to brand new, newly released, 2 days old integrations with Vault. Hopefully, I anticipate us to see a lot more integrations, a lot stronger integrations as time goes on.
And one question just came through. Is there built-in Terraform integration with GitLab 13.4? Is there built-in Terraform integration with GitLab 13.4?
So GitLab and Terraform have had integrations going back into the early 12.x releases, so more than a year old. It just continues to get better and better. I think the latest in 13.4 that I saw was some enhancements to some of the Terraform planning modules that allow us to get some of those Terraform plan reports back into GitLab.
I have there's a question. I'll just read it out loud because I don't know if it's within the context of what you were saying at the moment, but it says, how does this compare to GitLab managed Terraform state? So it might be related to
GitLab. I'll answer what Terraform managed state is, and then Kyle, if you want to kind of remind everybody where the differences are between cloud. So Terraform managed state is an HTTP-based backend for Terraform state files. So this allows your GitLab server to be a Terraform backend, but it's a very simple backend. It holds the basic state file and allows multiple people to use and collaborate it on a pipeline. Terraform Business or Terraform Cloud takes this to the whole next level. So, Carl, you want to highlight some of the differences there?
Yep. Yeah. So this is basically the comparison in remote backend types and where you want to store your state, what your organization's comfort level is with where those states are existing. As Brad was discussing, GitLab can host that as well within their environment, and Terraform Cloud can host that within our environment as well. Part of what we saw today through the demonstration was some of those additional capabilities through Terraform Cloud, such as that remote execution, meaning that we could use Terraform Cloud to actually run our plan and our apply operations directly within that software as a service-based offering, so that we didn't have any type of dependencies on running this on my or Brad's local laptop or any type of other development environments.
The question, the previous question that was already answered, is there a built-in Terraform integration with GitLab 13.4, was followed by the same person who asked that question by, without using HashiCorp Lite image when you run a build job. Yeah,
the HashiCorp Lite Docker image is just a quick way to have the binaries pre-installed. So it allows us to quickly spin up something we need to execute Terraform plans, Terraform formats, validates, et cetera. You are welcome to roll your own base image. So if you have something that you want to have multiple other tools in there, or different bits that you might need to access other services or do any kind of configuration management on top of that, you can have kind of your own base image. We just use Terraform Lite as the most generic and easy to start with.
Great. When will Terraform for Business be available? I know it is already, but you want to say something about that, Kyle?
Yeah, so it's already out there. It's available for use. We showed a production grade environment as part of our demonstration today. So yeah, go head out there and get started.
Yeah. Will the presentation question
Q&A.
answer and Q&A and or screens be shared after the webinar? Yes, indeed. This webinar is being recorded, and I'll make sure to send to everybody. It will usually takes a couple of days for processing, but we'll send it, of course. Any more questions? Any final comments from the speakers? All right, so with that, I will just basically thank everybody. First of all, thank Brad and Kyle, and thank you to the audience as well. I hope everybody enjoyed today's webinar and has a better understanding of GitLab and HashiCorp Terraform, how they work together. Finally, again, as I mentioned, even after the question, the webinar was recorded and will be made available in a couple of days. Stay tuned. We have more to come. Have a great day and goodbye, everybody.